Well, and let me briefly remind you some main points about references. Reference is a special variable that can be considered as a pseudonym for another variable. And this is a general form of reference declaration. Again, as you see, to declare reference, we use this sign, ampersand. I told you several times that the meaning of the sign depends on the place where you use it. Especially it related with the sign ampersand, because this sign has different meanings. And one of these meanings is a declaration of reference. If you use this sign in declarative statement. Type of the variable, after that this sign, the name of the reference, and the name of the variable. After that, this name, this identifier, and this identifier will correspond to the same variable. You have one variable and two names of this variable. Initial name and the reference. Let's briefly review it in Visual Studio. I comment this example that we consider previous lesson. I equals to 0 or to 1. Int sign of the reference, for example, p equals to I. Now p and I are the same name of one variable. If I assign something to p, for example, p equals 3, and after that I'll output to the screen the value of the variable I, in this case, I will see that the value of the variable is changed. Yeah, you see it. I equals to 3. Here I use another name of the variable to change the value of the variable. Of course, when you use only one function, like main function, this situation, seems very strange. Why we should declare a reference, why we should give another name for the same variable, but the declaration of the references is very useful when we need to pass parameters to the function. When you pass parameter to the function as a reference, it means that x will not a copy of actual variable, but different name of the same variable. And all the actions that you perform with variables with references x and y, all these actions will influence to their original actual parameters of this function. The actual parameters change the value too. comment this part of the program and uncomment this part. Suppose that I declare two variables a and b, the value of a before the function swap, before I call the function swap, and the values of a and b after this call. And you will see that the values of a and b are changed. But if I delete the sign of the reference here, in this case, do you remember how this way of passing parameters into the function called? When I write it like just double x without reference.
That's just using a function, right?
How this style, how this way of passing parameters into the function is called?
Using regular identifiers?
No.
Parameter?
Special name of this.
Pass by value.
Passing by value. Passing by value.
Oh, okay.
When we use a reference, is called passing by references. Reference. When we use this usual way, is called passing by value. The description is written here of this way of passing parameters. When we pass parameter by value, it means that a copy of actual parameter is transmitted into the function. And for this local copy, for this local object, the memory is allocated inside the function. And after the function execution, this memory is deleted. And the function operates with these local copies only. It means that the function cannot change the value of actual parameter. So when I pass here parameters by value, it means that not actual variables a and b will be transferred to the function, but copy of a and copy of b as x and y will be transferred here. And all the actions, all the operations will be carried out with x and y. X and y will be changed inside the function, but a and b are not. And if I run this program now, I see that a and b still be 1 and 2 after the function and before the function. This is very important. Please remember, if you want to be sure that your function doesn't change the values of parameters, you should pass parameters by value. But in the case, if you want that your function change the values of parameters, you should pass it by reference.
Okay.
Some question in the chat. Pass by value, yeah, it's the answer. Well, we consider these two options for passing parameters, but there is one more option that is called passing by address. In some cases, we can pass a pointer to a function. So we can use a pointer as a function parameter. In this case, when we use not an ordinary variable, but a pointer, the address of actual parameter is transmitted into the function. And as a result, the function gets access to actual parameter and can change it. Such way of data transmitted is called passing by address. So as you see, it's very similar to passing by reference. And this way of passing parameters, passing by address, is work in the program written in C, clear C language. And passing by reference can be used in C++ programs. So this is one of the differences between C and C++. When we write a program on C, we can use two ways: passing by references, passing by value and passing by address. If we write a program in C++, we can use all of these options: passing by value, passing by address, passing by reference. Well, let's consider their example. Here the example is written in on my presentation, but of course it's better to consider it in Visual Studio. Exactly the same example, but here I use int, in Visual Studio I use double. I think it doesn't matter. Passing by pointer, passing by address, it means that I pass a pointer here. Now x is a pointer to the variable x. To stress this, let me identify as px and py. So it's not a variable, it's not a double variable, but pointer to a double variable, px and py. Well, as far as px is a pointer, I can get access to the variable to which this pointer points. What operation I should use to do it? The operation of getting the access. It's written here, the operation star. Operation of getting their access. So, star px. It means that I assign to the variable s the value of the variable to which the pointer px points. Next line, I should change the values of x and y. And also I should use their pointers, px and py. This line means that I assign to the variable to which px points the value of the variable to which py points. And the final line, I should assign a new value to the variable to which py points, and this new value is s. After I call this function swap, these two variables will be changed. But how to use it? How to use it? So I think because the standard function swap from the namespace std exists, let me call this function mySwap. Swap written by me. Let it be mySwap, and I want to call mySwap. And you see that Visual Studio shows me the mistake here. I cannot use A and B because A and B are the values of the type double, but the function mySwap requires pointers to double. Pointer means the address, and to pass here a pointer, I should use the operation of getting the address. It's written here in this presentation. This is the main line, the main feature, the function. Here it's written, here it's name of the function is change. I can use it in my program too, not mySwap, but change. Or I can use it as mySwap, it doesn't matter. But the main point is that I should pass here not A and B, but the addresses of A and B. And to get the address of A, I should use the operation of getting the address, ampersand. And after I call this function, A and B will be changed. Let's check it. Yes, before the function call A and B was 1 and 2. And after the function call A and B are 2 and 1. Well, pay your attention that here the sign of the ampersand is used as an operation of getting the address. So a lot of meaning of this sign, a lot of meanings, and the meaning of the ampersand depends on the place where you use it. If you use this sign in declarative statement, it means reference. If you use this sign in computational statement, before identifier of a variable, it means getting the address. If you use this sign in computational statement between two variables, it means logical AND, operation AND. Different meanings of the ampersand. Well, I pass here two addresses and swap the variables using their pointers. Please look one more to this example. Look again to this example. Do you have questions about it?
So if you're using using a function with pointers, you have to use ampersand when you're calling the function.
Yes, right, but not in their all cases. Later, I show you the case where ampersand is not required. This topic, passing parameters into the function, is one of the most important topics, and there are a lot of features. Well, in some cases, you should use ampersand. But in other case, you can pass the parameter without ampersand. Later, I show you the example.
Okay.
Please, more questions.
No, sir. Just with pointers,
Well,
references, and by value. Understood.
Yes. Three main types of passing parameters. By value, it's a usual way. Then, by reference, maybe it's more simple than in comparison with passing by address. But in some cases, we need to this way of passing parameters by address. And now I want to show you the case where it's crucial, where we require to pass parameters by address and where we cannot use references. Well, about static variables I told you later. Now let's talk about array parameters. You will use it on practice. You use it on practice, and even I show you some examples with parameters of array types. But now let's consider it from another point of view, from the point of view of passing parameters. We discuss that we can pass parameter by reference, by value, and by address. And the question is how to pass the array into the function. And here we use some some feature that the name of the array can be considered as a pointer to the array, as a pointer to the first element of the array. And when you pass into the function the pointer, in this case, you can consider this pointer not as a pointer to one variable, but as a pointer to array, as a pointer to the first element of the array. In this case, in this example, I pass one parameter, one variable, and this pointer will be a pointer to the one variable. Let's consider the example. Let me call this function just func, and well, suppose that the function func gets a pointer p. This pointer can be considered as a pointer to the array. Wait a minute, I come back after a minute. Well, sorry. Let's continue. And suppose that we have a function func and a pointer p that is a parameter of this function. This pointer can be considered not as a pointer to one variable, but as a pointer to the array. But in this case, this function cannot decide. We cannot decide. We cannot. We don't know. Is it a pointer to one variable or is it a pointer to the array? Because these pointers are similar, and in this case, usually we should pass into this function the integer variable, the size of the array. It means that p is a pointer and size, the second variable, the second integer variable, it can be size, can be n, any integer variable can be considered as a size of the array. Well, it's written here in general form that the function with the name of the function has two parameters. First parameter is a pointer to the array, and second parameter is the size of the array. And in this case, we can consider this pointer as a pointer to the array of this size. And in some cases, we return the result. In some cases, this function can be without result. This is an example, but again, let's consider the same example in Visual Studio. Exactly the same example. We have a function func, and here I can work with pointer p as with the name of the array. For example, I can print the numbers to the screen. Now I comment this program. Now let's declare some array here. Array, for example, m. For example, let's assign some values here for the array. And after that, I can call the function func, and I can pass to the function name of the array and size of the array. Here, name is a pointer. Name of the array is a pointer to the first element of the array. Well, we see the result. This function prints the element of the array 0, 2, 2, 4, 5, and the rest of the elements are zeros, because I didn't assign it in this declarative statement, and these elements are zeros. Okay, now let's perform some.
But you didn't use the ampersand.
Yes, yes. Here is the case when I can pass the pointer, but in this case I didn't use the ampersand because m is not a variable. M is an array. It's not a variable like this, int a. It's not one variable.
Okay.
And
So
in
for
this case, yes, this is a difference. When you use just one variable, you must write ampersand. If you use array, you can use it without ampersand because the name of the array is a pointer.
Okay, got it.
Well, let me show you one feature again. There are a lot of features and I can show you it all the day. Well, now I call the function func and I pass to this function array m and size. And this function prints the elements. Okay, but what happens if I write here a? Visual Studio outputs me mistake because a is a variable, but function func should get here pointer. I can write ampersand. Now this program becomes correct from the point of view of compiler.
Yeah,
but
it doesn't make sense.
Yes, but it's not correct. It doesn't make sense because here a is just a one variable, but I try to use it as a name of the array. Let's check it. You see that compiler tells us, okay, succeeded. But let's check what happens when I try to run it. You see that the first number will be 10 because it's a value of a, but all of other numbers will be just undefined numbers, because I tried to use this name, not the name, but the pointer to the variable a is the pointer to the array inside this function. Is it clear? Do you understand this example?
Mm-hmm.
Well, pay your attention on it because compiler cannot help you. This can be checked only manually by programmer. Now this program correct because I use m. Okay. Now let me show you one more example. Suppose that after I print all the numbers, suppose that I write here something like m0, no, of course not m, but p0 equals to 100. Sorry again, I answered this call.
From
Okay, let's come back. Well, suppose that I assign 100 to the element with index 0. And suppose that I here the output green the first element of the array. So
It will change the first element because you did it after you called the function. No, you did it after you printed the
first.
Yeah.
What we see on the screen here. Will we see 100 or 0?
100.
100. Right. The answer is correct. We will see 100. Here I print the number, but I see 100. 100. Okay, but let's do the same with this n. N equals to 100. N equals to 100, and after that, let me print size. What we see as size?
Again, 100.
100.
Yes.
No. 10. We will see 10. Let's
you
discuss.
did it after. That's weird. Yeah.
Yes, we did it after, but let's discuss about it. Let's discuss. What is the difference between these two parameters, m and size? The difference is that the first parameter is passed by address, and the second parameter is passed by value. It means that in the first case, the function gets the pointer to this array. And for the second parameter, the function gets the copy of actual parameter. This size has value 10, but n will be copy, and all the assignment that I do here will be done with copy. I change copy, but the initial value still be 10. But here I change not p, but the actual parameter m, because I pass the array by pointer. Please remember, this is the main feature of C and C++, that the arrays can be passed to a function only by pointer. It means that all the changes with arrays element that you do inside the function, these changes you will see in the main function.
Okay. Does that mean you should pass the size also by address the same way you did?
No, I just if you want to change it, yes you do. You should do. But usually this is a typical situation. You pass the first parameter as a pointer to the first element, and the second parameter as an ordinary variable. You pass the second parameter by value. Well, the same is written here. When you pass here the array A, the type A6, the array of 6 elements, will be converted to pointer to the integer. And this implies that assignment to an element of an argument array changes the value of an element of the original array. Arrays differ from other types in that array isn't and cannot be passed by value, only by pointer. Well, more questions about it? Do you have any questions?
No, sir.
No. Well, now let's discuss about very important thing that called lifetime and scope of the variable. And let me show you this on very simple example. Suppose that I declare here inside the function some variable. For example, the variable s. Okay. And let's assign s equals to 10. Or even let it be a with the value 100. These two variables will be considered as different variables. This variable a with initial value 10 is accessible inside main function. This value a, this variable a with initial value 100 is accessible only inside the function func. And these two variables are considered as different variables. These variables are called local. This a can be used only here below its declaration. If I write a equals to 1, it will be a mistake because I declare the variable a below this line. I write a equals to 1 here, will be correct because I declare the variable a before this line. And the same can be said for the function. If I try to use a here before its declaration, it will be a mistake. If I try to use this identifier, this a after declaration, it will be okay. But these two variables are different variables. Again, this a can be used only here, only inside this function. This a will be used only can be used only here, only inside this function main. And these variables are called local variables. Local. Let me open one more presentation about it. Usually we use two basic objects in a program, constants and variables. And the main characteristics of these objects are the value of the variable and the name of the variable or constant. And only the difference is that the value of the variable can be changed in the course of program execution. But the the value of the constant cannot be changed. Cannot be changed. But the attributes are common: name, value, and type. So this constant has type int, name size, and value 10. This variable has type int, name a, and value 10. The value of the variable can be changed. The value of the constant cannot. If I try to do it, compiler outputs me a mistake. Okay. So the name is just an identifier. The attribute type indicates a type. Value is a concrete value of the this variable in concrete moment of time. But moreover, this information object, variable or constant, is stored in computer memory. And several cells of computer memory are allocated to store this information object. The size of the memory depends on the type of the object. We considered that, for example, for the type char, it is required 1 byte for storing, for the type int 4 bytes, for the type double 8 bytes, and so on. It means that the information object, the variable, exists if and only if there is a memory allocated to it. If we take away the memory from an information object, it ceases to exist. And there are two important questions. Who or what allocates memory for information object? And when does a data element declared in a program get the memory? We consider the answers to these questions, just maybe the main idea. We are not going into details. We consider the very simple case, one program. And usual solution, one of the possible solutions, is that compiler, during the compilation of the program, allocates the memory for the variables. This mechanism of memory allocation is called static, and such memory is called static memory. And so in this case, all of the memory for all of the variables are allocated by compiler in the course of program compilation. Another way of memory allocation follows the principle as required. The memory is allocated to a variable exactly at the moment when this variable is required. Such method of memory allocation is called dynamic, and the memory allocated on such way is called dynamic memory. Well, let me skip this slide. Now, when we compile the program, compiler combines static and dynamic principles when it compiles the program that you write. To understand how it works, let's consider two definitions. Definition number one. A sequence of two or more statements following one after another and enclosed in braces is called composed statement. And definition number two, composed statement containing declarative statement is called block. So from this point of view, the point of this definition, this is a composed statement, statements included into the figure brackets, and this is a block, a sequence of statements that includes declarative statements, one or more declarative statements. The same example in my presentation. Now, following these two new definitions, let's introduce a new attribute of variables and constant. Definition number three. The period of program execution during which an object exists is called lifetime. Lifetime of the object. The lifetime of an object can be global when the object exists from the moment of its declaration until the end of the program execution. This object is called global. And the lifetime of the object is called local if the object exists within a block in which it is declared. Such object is called local. Well, again, let me come back here. So this is a block, and this information object, this variable, is called local. It exists only inside this block, and it can be used only here. And the last definition, a part of the program in which information object can be used is called scope of the object. The object scope can be valid either up to the end of the block in which the object is declared, or up to the end of the program. So the variables or constants have the following 5 attributes: name, value, type, lifetime, and scope. And the lifetime and scope depends on the place where you declare the variable and depends on class of the memory of the variable. It means that programmer can control the lifetime and scope combined in 2 ways. First way is to use the place of object declaration in the program, and another way to use special keywords that corresponds to class of the memory when the object is declared. This is a usual form of declaration of the variable and the constant. How we declare a variable: type of the variable, name of the variable, and initial value. Here, initial value is optional. For constant, we use keyword const, type of the constant, name of the constant, and value of the constant. Initial value for the variable is optional. But also, there is one more parameter that called class of the memory that is also optional. And usually we will not use it. Usually we declare just int a or double x without any memory classes. But sometimes it's required to declare the variables with a concrete memory class. And there are 4 specificators of memory classes: outer, register, static, and extra. And maybe the most useful of these memory classes is outer, that is used by default, and static. We will discuss only about these 2 memory classes, because register and extra is not very useful. And there are 2 possible locations of object declaration in a program: within a block, it means inside the function, or outside the function, together with preprocessor directives. 2 possible options for declaration of the variable. When we skip the memory class of the variable, like here and here, the memory class outer is used. It means that this variable has local scope and local lifetime. It means that for this variable, temporary memory is allocated when we enter to the block. And if the block is completed, the variable ceases to exist and the memory becomes free. Let's consider it maybe in some example. let me write this loop here without function call. Only I should use here size and m. Okay. Let's check that the program is correct. This program is very simple. I just declare the array and print it to the screen. Okay. Now suppose that I declare inside this block some variable. For example, this variable a. Let me move this declaration here. This program still be correct. If I try to run it, it will compile and compiler run it. Well, now if I write here something like a equals to 1.
Oh, okay. It forgot.
It will be a mistake. It will be a mistake. Because a is a local variable and a has a local scope. I can use a only inside this block. And I cannot use outside of this block, even I will write this line below the declaration. If I declare some variable inside the block, I can use it only inside this block. And I cannot use it outside. This is the meaning of the words local scope and local lifetime. Maybe let me show this more. ++ and cout a. Suppose that I write such loop. Okay. What will we see on the screen?
We'll see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
But not from 0, not 0. What we see as the first element? Initial value is 1. After that, I write a++.
Yeah, 1 to 10.
No. Why
1 to 9.
No.
Okay,
Look to this program. Initial value is 1. After that, I write a++. And only after that, I write the output statement.
Oh, so you'll see 2 is the first element.
Yes, the first element will be 2. And we see the sequence 2, 3, or not. Not 2, 3, 4. Not 2, 3, 4. But just 2. And let's discuss about it. Why 2? Again, we see 2 because a has a local lifetime. I declare a here. After that, I compute a++, output to the screen. And the block is over. The block is over. We come back to the beginning of the block, and the a will be declared again.
Okay.
The a will be declared again, and after that it will have initial value 1, a++, and we output again, and we see 2. The main point here, that if the block is completed, the variable is deleted and the memory becomes free. And the outer variables without initial values are undefined. And for variables declared in a block, initialization is performed during every enter to the block. So when we enter to the block, the variable will be initialized. When we enter to the block again, the variable will be initialized again, and so on. When we have such loop, this initialization in line 33 will be executed at every iteration of the loop. A becomes 1. Please remember it. When you declare a variable, outer variable without any memory class, this variable will be initialized every enter to the block. Of course, if you declare in the beginning of the program here, for example, int b equals 10, this declaration is written outside the loop, and this declaration will be executed only once. But A will be declared and initialized 10 times at every iteration. Well, we have just 8 minutes, and I show you maybe the most important memory class called static. When the memory class is specified manually as static, then the variable or a constant declared with a static memory. The memory is allocated and kept until the end of the program. So the variable is not deleted when the program finished the block. But the variable is not accessible outside of the block. It can be accessible, it's accessible only inside the block. It means that the static variable that is declared in a block has local scope and global lifetime. And the main difference from outer variables and static variables is that for static variables declared in a block, initialization is performed during the first enter to the block. The initialization performs only once. Let's consider it in this example. Suppose that I declare this variable as static. to do it, I should use just write the keyword static before the data type. Now the variable a becomes static.
Oh, so just once.
It means that this initialization is carried out only once, when the program execute the line 34 for the first time. After that, we can use the variable a, but this line will be skipped. What will we see on the screen now?
2, 3, 4, 5, 6.
Right. In this case, we see 2, 3, 4, and so on. So initialization of static variables performs only once.
Okay.
This is the main difference between auto variable and static variable. Static variable also is not accessible outside of loop. If I write here a equals to 1, it will be a mistake, because this variable has a local scope, only inside this for. But it has a global lifetime. The lifetime is from the moment of declaration until the end of the program.
Okay.
Maybe we have just 3 minutes. I continue on the next lesson. We discuss again about the static variables. I show you one more example, very, very interesting example. Let me delete here. Int a equals to 1 and cout a. A++. And let's call the function func several times. For example, 3 times. The same question. What will we see on the screen?
2, 3, 4. Because a, wait, no, it's not static. So
It's
this
not
is 2, 2, 2. Yeah, 2, 2, 2.
Yes, we see only 2. A is not static. And when we call this function, the a will be initialized every time. Every time, this 1 will be assigned as initial value to a. And we see 2, 2, and 2. But if I declare this variable as static, this means that this initialization performs only once, only at the first time. And we see 2, 3, and 4.
Okay, yeah, I understand.
This is the main difference between usual variable, auto variable, and static variable. Well, there are some more features than we don't consider because we have no time now. We start our consideration on the next lesson. Well, now, if you don't have any questions, I stop recording.